In this example, guys, I'd like to go over my thought process for answering more complex questions like this one, right? We unfortunately ran out of time during the lesson, but I'd like to provide you with some help for these types of questions, okay? So we've just looked at all the equations for constant acceleration, and the reason we discussed that we have all these equations is so that instead of doing multiple stages to solve these types of velocity, displacement type questions, we can use one equation. It not only eliminates error, but it also simplifies our objective, okay? So we have those 5 equations that we have learned, right, which are given to you on your formula sheet, right? Well, most are. You would just have to derive one of the formula if necessary, okay? So here we have the equations that we would use. So I'm going to jump to this worked example here, right? It says we have a trolley, or a trolley has a constant acceleration. This is an important point that they make, because if we did not see constant acceleration, we would not be able to use our constant acceleration formula, right? After 2 seconds, it has traveled 8 meters. And after another 2 seconds, it has traveled a further 20 meters. Find its acceleration. So the first thing we notice here is this problem seems to be broken up into 2 stages. We have a displacement for the first 2 seconds, and we also have a displacement for the last 2 seconds. And regardless of the amount of information we have and all the formula we have, there is no formula that we can use to immediately find the acceleration, right? This leads us to conclude that we are going to have to create 2 simultaneous equations in order to solve this problem. So when we have multiple scenarios where we are going to be using the same equations, it's very important to start numbering your equations appropriately, right? And this is what I mean. Let's have a look at how this problem can be broken into 2 parts. We have 8 meters after 2 seconds. This is our first part. And we also have another 20 meters after the second 2 seconds. So let us write down the known and unknown information for these 2 separate parts. I know the displacement, and I'm going to call this displacement 1, right, is equal to 8 meters. I also know the time is 2 seconds. And at this stage, that's all I know about the first half of the trolley's journey. The second half, which I'm going to appropriately call displacement number 2, this is equal to 20 meters. And my time 2 in this case just happens to be the same at 2 seconds. Right? That just happened in this scenario. It could be different in a different question. Now, let's look at the unknown information, okay? We do not know the acceleration. We do not know the initial velocity. We also don't know the final velocity. And the same can be said over here. We do not know these variables. However, we can make some very obvious assumptions, okay? Because it's constant acceleration, we know that the acceleration for both of these is going to be the same, because the acceleration is not changing. Because these events are happening directly after each other, we can say that the final velocity for the first portion, right, is just exactly the same as the initial velocity for the second part. So V1 is equal to U2. And the initial and final velocity of the 2 separate ones, they are unfortunately not related. So based on this information, right, we now need to create 2 simultaneous equations, all right, in order to solve for these variables. And the ones we are going to try to solve for are these ones that are the same, okay? Because if they are the same, we can create simultaneous equations, right? Two separate simultaneous equations, and we can solve for these unknowns. So that will be our next step, to solve for these unknowns. Now, when we go about selecting formula, we need to think about which formula would be appropriate based on the information given. Let's go to the first half of the equation. In the first half of the equation, or the first part of the problem, the unknown that I'm not interested in is this initial velocity here, right? It doesn't play any factor for me solving it because it's not related to anything else in the second half. So I'm going to choose to use the equation displacement is equal to Vt minus a half at squared, right? Because it does not take into account initial velocity, right? Placing in my variables, I will get 8 equal to, we don't know the velocity, right? We do know the time is 2 seconds. We know that our acceleration is unknown. And again, we know our time is 2 seconds, but this time it's just squared. Simplifying this out, I'm going to get 8 equal to 2v, right? This is going to become 4 divided by 2, right? Which is just going to give me 2. So this will be minus 2a. And we could go a step further and simplify that, but we're going to leave this at the moment as equation number 1. Right, in the second part of the problem, my initial velocity is known, but my final velocity is unknown. And my unknown velocity at the end is not related in any way to my other equation. And so I'm going to choose the equation that does not include final velocity. And this is ut plus a half at squared. In this case, the displacement is 20. My initial velocity is unknown. And this is ut2, by the way. This is v1. Right? We're going to look at the comparison just now. They are the same. And this is plus a half. Acceleration is unknown. And time is again going to be 2 squared. This is going to give me 20 equal to u2 2 plus 2a. There's my second equation over there. Okay. So one very important thing now to remember is we said our acceleration must be the same, and we've also said that v1 is equal to v2, right? And so we can just simplify both our equations, right? Instead of saying v1 and u2, because they are the same, we're just going to call them both v for velocity. And so we have 8 equal to 2v minus 2a. This is equation 1. And I have 20 equal to 2v plus 2a. Now you can solve these simultaneous equations any way you like through substitution. I'm just going to use elimination. I'm quite simply going to just add these two equations together, right? Minus 2 plus 2a gives me 0. 2v plus 2v gives me 4v. This gives me 28. And so I can solve my velocity, right, is equal to 7 meters per second. Now, I wasn't asked to find the velocity, I was asked to find the acceleration. And so I will just use either one of my two equations to find the acceleration. So I can say 8 minus 2v, or sorry, 8 equal to 2v minus 2a. I can substitute in my velocity of 7 meters per second. And solving for a, I will get 3 meters per second squared. So that is the multi-stage process. So even though we have learned all these different constant acceleration questions, we can still not be provided enough information to solve the problem in one go, and we still need to think about making simultaneous equations. And remember, when you're making a simultaneous equations, you are trying to make two things equal to each other. So find your two equations, find the variables that you know to be equal, and solve. I hope this will help you if you have any further problems like this in the future.